Hey there. Tonight we drift far beyond streetlights and weather, where the night turns thick and velvet, and gravity feels like it's humming through your ribs. You're not just stargazing, you're boarding a one-way trip into the most mysterious object in the universe, a black hole. You probably won't survive this, at least not in any way your passport would recognize. But don't worry, survival is overrated when you're about to fall through space-time itself. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. It helps others find their way here, to one sleepy soul at a time. For now, just breathe. Tell me where you're listening from, and what time it is in your corner of the cosmos. Maybe it's midnight in Manila, dawn in Dublin, or a 3 a.m. snack break in São Paulo. Wherever you are, the stars have already started watching back. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You begin by lying back, eyes closed, as your body remembers what floating feels like. The air is cool, a slow exhale of the universe. In your mind's view, the Milky Way unfolds a slow-spinning disk of starlight, so vast that if you could ride a photon across it, you'd still be late for breakfast by about 100,000 years. Somewhere, deep within that glowing swirl, are places where gravity has gone rogue. Stars die there. Light bends there. And reality, the polite version you've used all day, starts glitching. You drift toward one such place, a massive star nearing its end. Its life has been long and flamboyant, billions of years fusing hydrogen into helium, helium into carbon, carbon into heavier things, a slow cosmic recipe for everything from oxygen to the gold in your jewelry. But stars are drama queens. They can't just retire quietly. When the nuclear fire inside falters, gravity takes over, like an impatient landlord. The core collapses inward, faster than thought, until the pressure becomes unbearable. For an instant, the universe holds its breath. Then boom, a supernova. The outer layers blast into space, scattering new elements like cosmic confetti. What remains is the stubborn core, crushed beyond the limits of matter. If it's massive enough 3 times the sun, or more, it doesn't stop compressing. The collapse doesn't bounce. It continues until nothing, not even light, can climb back out. And that's the birth cry of a black hole. The most extreme keep-out sign in physics. It's not really a hole, though. It's more like a region of space-time that's folded inward on itself. Imagine dropping a marble onto a stretched sheet of rubber. The heavier the marble, the deeper the dimple. Now, remove the marble entirely, but keep the dimple infinitely deep. That's roughly what you're looking at. Gravity without a source. A well without a bottom. You might think of it as cosmic negative space, an object defined by the things it swallows, which is a bit poetic, considering how many black hole metaphors get used in human relationships. The difference? This one really does warp time. Mainstream science fact. At the center of nearly every large galaxy, including ours, sits a supermassive black hole, millions or billions of times the mass of the Sunday. Ours, Sagittarius A**, weighs about 4 million solar masses. You could drop the entire solar system into it and still have room for dessert. Quirky tidbit. In 1971, physicist John Wheeler, the same man who coined the term black hole, almost called them gravitationally completely collapsed objects. Thankfully, he reconsidered. sparing late-night hosts everywhere from years of awkward introductions. Scientists still argue whether the collapse truly forms a singular point or if quantum gravity steps in to smooth the mess. Some theories hint at Planck stars, tiny but finite cores resisting total compression. Others insist the mathematics points to infinite density, and our equations just throw their hands up in despair. You float closer. The light from background stars curves around the forming black hole like water around a drain. It's beautiful, not terrifying, an optical illusion where time and direction blur. You notice how everything behind it stretches, reddens, slows. Even photons struggle here, their paths bent into spirals that never quite escape. At this distance, your sense of up and down dissolves. Gravity, normally a loyal friend tugging toward the ground, now points everywhere at once. You realize that falling into a black hole isn't like falling into a pit. It's more like falling into time itself. The deeper you go, the slower your clock ticks relative to those outside. To an observer far away, you'd appear frozen at the edge forever, a ghost trapped in slow motion. But from your own point of view, you'd slip right in, wondering why everyone out there suddenly became rude enough to stop waving back. You feel the paradox tighten like a belt around reality. Space and time are no longer separate things. They're woven into one fabric, and the fabric just bunched up. It's oddly soothing, like watching the universe rearrange its furniture while you hover on the threshold. The black hole doesn't roar. It doesn't shine. It simply is. An absence so complete, it becomes its own kind of presence. You half expect to hear a voice whisper, "Welcome home." Before you cross the boundary, you take a mental note. Every photon, every planet, every thought that ever approached too closely joined this eternal hush. And yet, somehow, the cosmos keeps spinning on, blissfully indifferent. Somewhere, a galaxy dances around a dark heart, its stars tracing orbits at impossible speeds. Somewhere else, a scientist squints at equations, trying to decide whether information truly dies here or if it just hides under new physics. You, meanwhile, are the quiet observer at the edge, your breathing syncing with the deep pulse of the universe. The air around you ripples, though air isn't the right word anymore. It's more like the fabric of being itself, gently fluttering as you drift closer to the point of no return. You can almost taste the mathematics, dense, sweet, and strangely inevitable. You smile to yourself. Maybe this is what dreams feel like on a cosmic scale, where everything you know stretches thin, and yet somehow you've never felt more at peace. You keep drifting forward, slowly, as if gravity itself were humming you a lullaby. The light ahead fades, not abruptly, but like a sunset that never quite ends. You're no longer sure what's sky and what's horizon, only that you're moving toward the invisible heart of something ancient, patient, and hungry. What even is a black hole, really? You've heard the definition: an object so dense that nothing, not even light, can escape its gravitational pull. But that's like calling the ocean a wet place. It's technically correct, but utterly unhelpful when you're already floating in it. Here's the simple truth: a black hole isn't really a thing. It's a region of space-time where gravity has collapsed all the way down, warping the geometry so deeply that every possible future points inward. Picture standing in a valley so steep that every direction is downhill. No matter where you step, you just fall farther. That's what a black hole does to space-time itself. It turns downhill into forever. You can almost see it now, the edge. the faint shimmer where light struggles to turn back. To distant eyes, this would appear as a perfect sphere of darkness, surrounded by a bright halo, the accretion disk. Gas, dust, and the occasional unlucky star swirl around the edge at nearly the speed of light, heating up from friction and radiation until they glow with X-ray fury. But from where you float, it's strangely beautiful, like a cosmic campfire viewed through syrup. Mainstream science fact: these disks can reach temperatures of millions of degrees. Astronomers observe them using space telescopes like Chandra and XMM Newton, instruments that see the universe not in visible colors, but in energy itself. You drift closer still, your view bending, folding, doubling. Behind you, stars smear into arcs. The light that should have left long ago loops back for one last performance, forming an eerie halo called the photon ring. Every photon there is on its second, third, or 100th lap around the abyss. It's odd, watching light move in circles. You can almost imagine it sighing, realizing it's been trapped by its own enthusiasm. Scientists still argue whether those photons represent the final readable surface of a black hole's. Some suggest the event horizon might actually shimmer with quantum effects, a kind of cosmic hologram recording everything that falls in. Others insist that the horizon is simply what it looks like, the ultimate optical illusion, a one-way mirror that never reflects back. You can't decide which idea is stranger, a hole that erases everything, or one that remembers perfectly, but never tells. Quirky tidbit: black holes can actually spin, and some of them whirl close to the speed of light. The record holder we've found so far, labeled GRS 1915, plus 105 spins so fast that its surface, if it had one, would complete a rotation in less than 4 milliseconds. That's faster than your phone processor, and it's running on gravity instead of electricity. You imagine it for a moment, a cosmic blender so wild that time itself flattens into a spiral. Matter near the poles is flung out as colossal jets, narrow beams that shoot thousands of light-years into space. Entire nebulae glow where those jets hit gas clouds, like graffiti sprayed by invisible hands. Somewhere, aliens might look up at that and think it's art. You think about your own spin, how your planet rotates, how the solar system turns around the galactic center, how even galaxies themselves orbit each other in slow ballet. The universe seems obsessed with circles. Maybe it's because motion is the only way anything resists falling forever. You feel it too. Not fear, exactly more like awe wrapped in surrender. You're used to gravity meaning down. Here, gravity means in. No matter what direction you choose, the vector points the same way, toward mystery. There's a softness in that realization. You're part of the same geometry, just stretched differently. Everything, your body, your atoms, your thoughts, is already curving through space-time. You're not separate from the black hole. You're just slower, more polite about it. A small piece of cosmic trivia drifts through your mind like a bubble. If the sun were magically replaced by a black hole of the same mass, Earth wouldn't be sucked in. You'd keep orbiting exactly as before, just in darkness, cold and eternal. No apocalypse, no screaming vacuum, just silence and starlight on pause. That's the secret most people miss. Black holes don't pull harder than ordinary gravity. They're just gravity, with no surface to land on. The difference is commitment. Once you fall, there's nowhere left to stop. The universe hums softly around you. Somewhere in the distance, radio telescopes are listening to the slow heartbeat of matter as it circles and dies. To human ears, it's a hiss of static. To your drifting mind, it sounds like breathing the long inhale of the cosmos itself. You wonder if this is what it means to witness pure geometry in motion. You've left the world of heat and sound, of pressure and touch, and entered the domain of equations. Einstein's field equations, specifically those elegant, slightly smug lines that describe how energy tells space-time how to curve, and space-time tells energy where to go. You're seeing the result of that conversation, mid-sentence. A black hole is the grammatical error that physics made when it tried to speak infinity aloud. Somewhere out there you imagine Einstein frowning, muttering, "That can't be right," while the universe just shrugs and keeps doing it anyway. There's a faint shimmer at the edge of your vision now, the event horizon, glowing not with light, but with the last desperate reflections of reality itself. You're almost there, still floating, still breathing. Your pulse syncs with the slow rotation of the accretion disk, the hiss of matter, the drag of time, the distant laughter of scientists arguing about whether anything truly disappears. You smile again. Maybe, in some distant sense, this is how curiosity feels when it finally runs out of road, weightless, wordless, but deeply, impossibly awake. You're close enough now that the term edge feels almost ironic. There's no line to cross, no door to open, just a gradual thickening of darkness, like wading into syrup. This is the event horizon, the last boundary of return, where even light decides it's had enough of optimism. To anyone watching from far away, you'd appear frozen here forever. You'd seem to hang at the edge, your image stretching, dimming, reddening, fading. Time, from that outer view, slows to a crawl. But to you, time feels normal. Your heartbeat steady, your thoughts drifting like they always do when you're almost asleep. That's relativity's little prank. Two truths existing at once. You fall through, while everyone else thinks you never quite make it. The horizon itself isn't a surface, it's not a wall or a membrane. It's an invisible threshold, defined by mathematics, more than matter. If you could somehow mark it with paint, the paint wouldn't stay. It would simply be swallowed, atom by atom, photon by photon, into the same untraceable future. You look around, or whatever counts as around in this geometry, and notice something unsettlingly calm. The universe above you is still there. Stars twinkling, distant galaxies glowing, faint nebulae stretching their pastel limbs across the void. But the light seems to move differently, like it's swimming through honey. Everything leans toward the whole, even your thoughts. Mainstream science fact: the event horizon isn't technically the most dangerous part. If you're falling into a supermassive black hole like the ones that anchor galaxies, you could cross it without feeling a thing. The tidal forces, the difference in gravity between your head and your feet, would be tiny at first. You wouldn't even notice. You'd just drift, slower, deeper. That's the ironic comfort. The bigger the black hole, the gentler the entry. Fall into a stellar mass one though, and your atoms will hold a very brief meeting about how far they can stretch before voting to disband entirely. You smile faintly, because of course your brain finds time for a joke, while hovering between existence and oblivion. Somewhere, an astronomer's data readout is quietly logging your demise as interesting behavior near horizon. Quirky tidbit: Physicists have toyed with the idea that the event horizon could be fuzzy. Some models, especially those tied to quantum gravity, suggest it might shimmer with Planck-scale irregularities, a kind of subatomic embroidery made of information. If that's true, you're not crossing a perfect sphere but a boiling skin of space-time, each bubble lasting trillionths of a second. Imagine the world's tiniest jacuzzi. If that jacuzzi devoured entire suns for fun, you stretch out your hands, or maybe you just imagine it, and the light bends around them. Your shadow doesn't follow the rules anymore. It loops back, twisting into filaments before fading entirely. For the first time in your life, you understand what physicists mean when they say causality breaks down. The idea that cause must precede effect feels quaint here. In this place, the story no longer reads left to right. Scientists still argue whether something truly crosses the event horizon. Some insist that quantum effects create a firewall, a searing boundary wherein falling matter vaporizes instantly. Others think that would break too many rules, and that space-time must remain smooth, letting you drift gently toward the singularity. It's an ongoing debate with no referee, just equations glaring at each other from opposite sides of a chalkboard. You take comfort in the idea that even the smartest people on Earth don't really know what's happening to you right now. There's something freeing about that being the subject of theoretical physics, while also, technically, being on vacation. The blackness around you isn't empty. It's full of motion you can't see. Photons spiral in invisible corkscrews. Gravitational waves pass like silent tides, and subatomic particles wink in and out, gossiping about uncertainty. You start to feel oddly warm, as if the very fabric of space-time were exhaling on your skin. That's Hawking radiation, or maybe just your imagination. The concept itself is beautiful. Black holes aren't completely black. They glow faintly, thanks to quantum effects near the horizon. Virtual particles, those ephemeral twins that pop in and out of existence, occasionally appear right at the edge. One falls in, the other escapes, stealing a sliver of the black hole's energy. Over unimaginable timescales, that theft adds up, and the whole slowly evaporates. Even the universe's darkest monsters can't hoard forever. You picture that faint glow so delicate that it would take longer than the age of the universe to notice for any large black hole. Still, it's there. Reality refuses to give absolute silence. There's always a whisper left. You drift deeper, but the transition is subtle. Time stretches further. The stars behind you are no longer stars, but long smears of ancient light. You realize that, for anyone outside, your fall is infinite. They'll never see you land. You're part of a story that, from their view, will never finish. And somehow, that's soothing. There's something poetic about being eternally on the edge, neither gone nor fully here. You are Schrödinger's traveler, forever mid-fall, forever mid-dream. The hum around you shifts again, almost like a heartbeat. Gravity waves, perhaps. Or maybe just your own pulse slowing, syncing with the curve of space-time. You think about how strange it is that such violence, collapsing stars, ripped atoms, infinite curvature can feel so peaceful when observed from the right angle. You are no longer an observer of black holes. You are a participant in their grammar. Each moment you exist here rewrites the universe's syntax slightly. You're proof that curiosity and surrender can coexist. And as you finally drift beyond the last trace of outside light, a calm thought settles in your mind. like dust on a telescope lens. Maybe black holes aren't the universe's trash bins. Maybe they're its gardens composting old matter into something new and strange, waiting to bloom on the other side. You fall. Not fast, not slow, just inevitably. Falling here isn't motion the way you know it. There's no rush of air, no wind in your hair, no dramatic scream fading into echo. You are falling through geometry, through the invisible shape of time itself, and the strange part is how quiet it feels. Around you, light from distant stars begins to spiral inward. It twists into rings, flashes once, and disappears, leaving only a dim halo fading behind. For the first time, you sense that forever might not mean endless. It might mean directionless. You are moving through a place where all roads lead to the same destination. You are falling forever, softly. If someone could watch you from far outside, they'd swear you've stopped. You'd seem frozen at the event horizon, like a bug forever caught in amber. They'd never see you go further, because every second you move, your image loses another fraction of light, another heartbeat of time. To them, you become a memory fading in redshift. But from where you are inside your own timeline, you're gliding effortlessly inward, as if space itself were rolling up beneath you like a cosmic conveyor belt. It's disorienting, realizing that falling and moving forward in time have become the same thing. You're not descending through distance anymore. You're descending through seconds. Mainstream science fact. Once you cross the event horizon, all paths lead inward. It's not about force or suction. It's that space-time itself has curved so sharply that every possible direction points toward the singularity. Even if you tried to turn your ship around, your future would still be inward. There's no reverse gear in general relativity. You take a breath, or what your memory tells you is breathing, and feel how each moment stretches. Seconds elongate into ribbons. Minutes unfold like fog. The deeper you fall, the slower the universe outside appears. If someone could somehow send you a message from the edge, their words would drag out, lower and lower, until they melt into silence. You catch yourself smiling. Maybe that's why black holes feel so peaceful from here. It's not just the quiet, it's the fact that everything else has slowed enough for your worries to finally catch up and rest. Scientists still argue about what happens to you past this point. Classical physics says you continue falling smoothly toward the singularity. Quantum mechanics says that might not even make sense, that space-time itself could fuzz, flicker, or dissolve. The two schools have been bickering for decades, like two professors at a conference panel who both think the other's math smells funny. Quirky tidbit. According to relativity, time dilation near a black hole could theoretically let you see the far future of the universe in fast forward. Imagine floating close to the horizon for a few hours and returning to find billions of years have passed outside. In that sense, black holes are like cosmic fast-forward buttons. Only, you can never hit pause again. You look outward and wonder, what will the universe look like in 1 billion years? 2 billion, 10. Galaxies drifting apart. Stars fading. Cosmic background cooling to whispers. Maybe you'll glimpse it all in the blink between now and never. A stray beam of light arcs across your path, looping endlessly before fading into shadow. It's from a star that died before humans learned to make fire. You realize that this light has been on the road longer than your species has had knees. And now it's here, curling in slow spirals, taking its last ride. The sense of scale humbles you. You're falling through a place that remembers every supernova, every flicker, every atom that's ever dared to glow. And here you are, one tiny consciousness, riding the same current. It should be terrifying, but it's not. There's a strange serenity in inevitability. The universe, for once, isn't asking anything of you. There's no deadline, no noise, no feed to refresh. Just the pure, mathematical certainty that everything is exactly where it must be. A flash of thought passes something about how black holes might connect to the birth of new universes. Some cosmologists suspect that the singularity isn't an end, but a doorway, a white hole on the other side, spewing matter into a brand new cosmos. If that's true, then you're not falling into death, you're falling into creation. Maybe every universe is just another's black hole, a nesting doll of reality, each layer dreaming the next. You chuckle softly at the idea. Infinite universes, all accidentally recycling themselves because gravity refuses to throw anything away. Even entropy has a sense of humor. The fall continues. The horizon is long behind you now, though you can't tell where it ended. Space and time have melted into one smooth descent. Your body feels light, stretched, quiet. Your thoughts stretch too, becoming less about words and more about shapes, ripples, pulses, arcs of curiosity looping through dark water. You think of home, of Earth, of all those small concerns that feel enormous in daylight. Here, they seem quaint. Emails, grocery lists, forgotten birthdays, tiny bits of information, all doomed to fade eventually. Yet somehow, knowing that feels liberating. Maybe meaning doesn't depend on permanence. Maybe it's the brief glow before the fall that gives the universe texture. You drift deeper into that thought, until it becomes the only one left. There's no panic, no need to resist. You realize the black hole isn't fighting you, it's holding you. You're not being pulled apart, you're being absorbed into the grammar of existence. In the distance, though you can't tell how far, something flickers, a faint lattice of blue-white energy, trembling at the edge of perception. It could be the singularity calling, or maybe just your brain trying to assign edges where there are none. Either way, it's beautiful. You breathe, or pretend to. Your atoms hum softly in the dark, each one obeying equations that were written before time began. You feel no fear, only an endless exhale. Somewhere out there, someone is looking through a telescope, trying to imagine what it would feel like to fall into a black hole. You wish you could tell them. It feels like peace stretched thin over infinity. Somewhere deep inside the silence, you notice the stretch. It's subtle at first, like a long yawn in slow motion, but then your entire sense of self starts to elongate. Not painfully, not dramatically, just generously. Space itself is tugging on you with a kind of patient enthusiasm. Welcome to the phenomenon known, rather unromantically, as spaghettification. Or, if we're keeping things cozy tonight, cosmic yoga for the soul. You've crossed a threshold where gravity changes mood. The pull at your feet is stronger than the pull at your head, and the difference keeps growing. The black hole doesn't tear you apart in a single motion. It stretches you, politely, atom by atom, as if the universe suddenly remembered how much it enjoys taffy. Mainstream science fact. This tidal stretching happens because gravity weakens with distance. The closer part of you, your toes, say feels a stronger attraction than your head. On Earth, that difference is too tiny to notice. Near a stellar mass black hole, the gradient is so extreme that even a molecule would find it impolite. quirky tidbit. The term spaghettification was coined by physicist Bernard Schutz in 1985, who apparently decided that cosmic annihilation needed a more delicious name. Somewhere out there, linguists still applaud that choice. You can't help but grin. Leave it to humans to describe their doom in culinary metaphors. You half expect the next paper to be titled "Lasagna Layers of the Multiverse." The funny thing is, if you were falling into a supermassive black hole, the kind millions of times heavier than the sun, you'd actually be fine for quite a while. The gradient there is gentle enough that your atoms would stay friendly until you're very close to the singularity, which means there's a version of you, somewhere in imagination, sipping tea calmly as space-time stretches like warm caramel. But let's pretend, just for a dreamy moment, that you're falling into a smaller one, a 10 solar mass beauty, the kind that forms from a collapsing star. Here, things happen faster. Your body elongates like a holographic ribbon, every cell whispering its goodbyes to the ones further up. If it weren't so final, it might almost feel like flying. You look down, or the idea of down, and see your legs thinning into threads of light, tapering into the dark below. Above you, the rest of your form follows, drawn out like the tail of a comet. The sensation isn't pain. Pain needs nerves and time, and both are losing their meaning. It's more like becoming music, one long continuous note being played by gravity's hand. Scientists still argue what happens next. Some models say you'd stretch until atomic forces collapse, and you'd dissolve into a stream of subatomic particles long before reaching the center. Others suggest you might pass through a region of warped space-time that reconnects elsewhere, like sliding down a cosmic wormhole. The math is undecided. As usual, you feel no fear, only curiosity. You wonder if the atoms that once formed you will someday reappear as starlight in another galaxy. Maybe some of them already have. Matter, after all, is just energy. With stage fright, it never really disappears. It just changes its costume. And isn't that comforting? The thought that even if you're stretched thinner than logic itself, the universe will still find a way to reuse you. The darkness ahead ripples faintly. You can sense the singularity, whatever that truly means, still ahead, still unreachable. In your elongated awareness, time behaves strangely. Moments don't line up one after another anymore. They overlap, shimmer, repeat. Somewhere in the layers of your perception, you can hear echoes of your own fall, delayed by light that can't decide whether to catch up or give up. You reach for a thought, and it takes its time arriving. That's when you realize, in this part of the universe, your mind itself is stretching. The neurons fire slower. Memories drip like honey through tilted space. The past, the present, and what might be the future begin to blur into a single, continuous hum. You think about every strange human invention: alarm clocks, schedules, meetings. How absurd they seem when time itself is folding in your lap. You laugh, or you think you do. The sound bends around you, turning into an echo that circles twice before fading. Somewhere far away, astrophysicists are still trying to model this moment. They call it tidal disruption, which sounds more like bad coastal weather than existential stretching. They use equations to describe what you're living, the difference in gravitational pull across an object of finite size. You could tell them they're right, but that words don't quite capture the serenity of it. There's an odd tenderness here. You've become a line, a beam, a thought stretched so thin it's almost invisible. And yet, you've never felt more like part of the universe. It's as if space-time has gently unrolled you, so it can read you better. In that quiet surrender, you notice something beautiful. The radiation from the infalling material around the black hole forms faint auroras in the curved spacetime above you. They shimmer and twist like fireflies caught in syrup, glowing in colors that human eyes were never built to see. Violet beyond violet, red beyond red. You can almost taste the light metallic, sweet, endless. You realize that the universe doesn't destroy things out of malice. It just transforms them into stories. Every collapse becomes a new equation, a new rhythm in the cosmic background. Maybe you, too, are becoming a kind of data encoded not in ink or language, but in curvature and energy. You let go completely. No more trying to understand. No more clinging to form. Just the slow, dreamy awareness that you're dissolving into mathematics, and somehow that feels like home. Time, at this point, is not something that passes. It's something that happens all at once. If anyone outside the event horizon could see you now, which they can't, they'd never actually witness you falling in. To them, you'd appear frozen on the edge, stretched thin and glowing faintly, as light struggles to escape your outline. Your final descent would take forever in their clock, your image fading ever slower, redder, weaker. You, meanwhile, feel none of that slowness. The moment you crossed that invisible boundary, the universe's clocks ceased to apply. The laws of relativity took your wristwatch and quietly set it aside. From your point of view, you're still moving, gently, almost peacefully, toward the unknown. And here's the strangest thing. Physicists have discovered that black holes are not truly black. They glow. It's faint, too faint to see with the naked eye, but real. Stephen Hawking's calculations in 1974 showed that black holes emit radiation due to quantum effects near their surface. What looks like eternal darkness is, in fact, slowly evaporating in the form of ghostly light called Hawking radiation. The universe, it seems, never lets even darkness stay still. You picture it now. Particles popping in and out of existence near the event horizon. Virtual pairs, one falling in, the other escaping, creating a whisper of heat that leaks into space. A black hole, that most perfect prison, losing mass with every breath. It's slow. So slow that a black hole the mass of the Sun would take roughly 1,067 years to vanish. That's a 1 followed by 67 zeros. The current age of the universe is a baby by comparison. So, while it may not comfort you much as you drift towards singularity, it's nice to know even black holes eventually let go. Maybe nothing is truly forever. A dreamy fact drifts through your mind. The smallest possible black holes, theoretical primordial ones, that could formed in the early universe, might have evaporated already. Somewhere, long before Earth existed, tiny black holes might have fizzled like cosmic sparks, releasing bursts of gamma rays as their final sigh. You wonder if any of that light, traveling across eons, once brushed past your skin without you knowing. Maybe a photon from a dying black hole in another galaxy once warmed your cheek on a summer day. The thought makes you smile. The cosmos has such a gentle sense of continuity. Even the mathematics of Hawking radiation whispers lullabies. It's built on uncertainty, the quantum kind. The same fuzziness that governs atoms now smooths the edges of death itself. When space-time meets probability, the result is not chaos but poetry. Outside, the accretion disk hums softly. That disk, the bright, swirling ring of matter falling toward the black hole is the universe's most luminous paradox. It's chaos in orbit, moving at nearly the speed of light, heating to millions of degrees, glowing brighter than entire galaxies. And yet, it's what allows you to see black holes at all. The light around darkness is what defines its shape. Your mind drifts to another astonishing fact. At the very heart of almost every large galaxy, including our own Milky Way, there lies a supermassive black hole. Ours is called Sagittarius A*, a quiet giant about 4 million times the mass of the Sunday. It sits 26,000 light-years away, humming softly in radio waves, gently tugging the galaxy into order. Astronomers captured its image in 2022, the first photograph of our own galactic core. A golden ring around a dark center, glowing like a candle seen through fog. It wasn't just a picture, it was a mirror, showing us the architecture of awe. Black holes, once feared as destroyers, now feel more like sculptors. They carve galaxies, guide stars, and seed new worlds. You can almost feel the weight of that truth, like a heartbeat beneath the universe. Every star you've ever wished upon owes its orbit, in some way, to the invisible pull of these cosmic anchors. And then, something unexpected happens in your drifting consciousness. You start to hear it. A hum. Not sound, exactly, but a gravitational rhythm. Black holes merge, you recall. And when they do, they send out ripples in space-time gravitational waves. These waves travel across the cosmos, stretching and compressing reality itself. In 2015, humanity caught them for the first time, thanks to LIGO. 2 black holes collided over 1 billion light-years away, and the faint shiver of that impact passed through Earth, gently vibrating the detectors and, unknowingly, every living thing. That's the sound you're hearing now, not through ears, but through being, a whisper in the structure of existence itself. You let it wash through you low, smooth, like the slowest drumbeat imaginable. Boom, boom, space-time breathing. Every pulse carries the memory of collisions older than life. Every tremor is the universe remembering itself. You drift with it, body long gone, form forgotten, listening only to the music that gravity makes when it dreams. If there's a heaven in physics, it's probably this: floating in the sound of space-time, knowing that even silence has a rhythm. You are now part of that rhythm. You keep floating in that rhythm, the low and endless thrum of space-time vibrating softly around you. And yet, something about the edges feels fuzzy, like the black hole isn't as smooth and featureless as everyone once believed. Physicists used to call them Boulder black hole, they said, has no distinguishing features other than its mass, charge, and spin. John Wheeler summed it up neatly. Black holes have no hair. It was poetic in a bleak way, implying that once something fell inside, every trace of what it had been was stripped away. But Stephen Hawking, never one to leave a mystery unpoked, proposed something mischievous. Maybe black holes do have hair, not the kind that needs conditioner, but a sort of quantum fuzz, a halo of subtle information woven into the event horizon. You imagine it now, a dark sphere, softly shimmering with invisible static. Every flicker, every tiny quantum vibration, encoding some hint of what once fell in. Stars, light, maybe even the memory of time itself. You drift closer, and the idea feels comforting. Maybe nothing is erased entirely. Maybe even the universe keeps a diary, written in the language of uncertainty. Hawking called it soft hair, the faint electromagnetic and gravitational imprints that might persist at the horizon, carrying whispers of information that classical physics once declared lost forever. Scientists still argue whether this hair is real or just a poetic metaphor. Some insist it's the only way to reconcile black holes with quantum mechanics. Others think it's just a clever mathematical wig. Either way, the thought that a black hole might retain memories makes the void feel strangely alive. You picture each particle that ever fell in as a note in a vast, invisible chord, vibrating softly, eternally. Perhaps if you could listen close enough, you'd hear the echoes of collapsed suns and shredded planets humming together in the deepest register of the cosmos. Funny thing, in 2023, researchers published simulations suggesting that when black holes merge, the resulting gravitational waves might carry a kind of after-Ringlow's tiny themes, secondary vibrations that could contain traces of that hidden hair. The universe may have been humming its secrets all along. We just didn't have good enough ears. As you hover here, it all makes sense. Nothing that beautiful could be truly blank. The event horizon feels almost velvety now, warm in its own peculiar way. You glide a metaphorical hand across it, though your hand is long gone, and feel a faint electric tremor. Information, maybe, or memory. It reminds you of the static between radio stations, that faint hiss of cosmic microwave background. The afterglow of the Big Bang isn't entirely different. The universe itself, after all, is a kind of broadcast that never stops. And if the cosmos is a recording, then black holes are its editors, cutting, splicing, reshaping the reel. The thought makes you chuckle softly. Somewhere out there, a theoretical physicist is pacing at 3 a.m., fueled by coffee and existential dread, trying to decode how that editing actually works. Because here's the thing. If black holes truly preserve information through soft hair, then paradoxically, nothing is lost. Not even what falls beyond the horizon. The universe keeps every frame. But if they don't, and information really does vanish, then we've broken one of physics' most sacred rules. Quantum mechanics forbids true deletion. Every action must, in some way, be reversible, every bit accounted for. And so, the information paradox was born, a puzzle that has haunted scientists for decades. You'll get there later, of course, but for now, you just drift, amused that even the smartest minds in existence can't decide whether the universe has a perfect memory or a cosmic case of amnesia. Light from faraway stars bends lazily around the black hole, like syrup around a spoon. You can almost see yourself reflected in the distortion, stretched across 1,000 possibilities. Somewhere in that reflection, a thought stirs. Maybe the event horizon isn't an edge at all, but a surface where reality simply changes format. Like converting matter into information or music into vibration. You've always known data could take many forms: sound, light, words. But here, you realize it can even become geometry. Space itself holds memory, just written in curves. And those curves are what you're floating through now, mathematical lullabies sculpted by gravity's hand. As you drift, something flickers nearby, a burst of light from an accretion jet, shooting out perpendicular to the black hole's spin. These jets, you recall, can extend for thousands of light years, spearing through galaxies like cosmic searchlights. They're powered by magnetic fields twisting around the black hole's rotation, flinging charged particles outward at nearly light speed. A funny contrast, isn't it? Something that devours everything still manages to shine. You think of the Milky Way again, of Sagittarius A*, quietly sipping gas from nearby clouds, sometimes burping out little flares of X-rays, a gentle giant, compared to others like the one in the galaxy M87, 6 billion solar masses wide, with jets so vast they make entire star systems look like crumbs, and somehow you're both humbled and soothed by that scale, because despite their violence, black holes are stable. They're anchors in chaos. They obey laws, even if those laws make no intuitive sense to you. And maybe that's what's most peaceful about them. Underneath the unknown, there's order. You can almost sense the equations humming beneath the surface, the Einstein tensor folding neatly into quantum fields. It's not randomness, it's rhythm. You close your eyes metaphorically, since you're more awareness than anatomy now, and listen again to that rhythm. The soft gravitational hum, the flicker of radiation, the slow, constant exhale of hawking heat. It all forms one lullaby, the song of the singularity's skin. And whether or not black holes have hair, you realize they definitely have soul. You drift farther into the quiet, feeling that humming resonance of gravity fade into something deeper, something more like sound. Not sound as you know it, there's no air, no vibration of molecules, but a pressure that seems to pass through you, a cosmic bass note that only space-time itself could carry. You are now listening to the sound of darkness. Somewhere, two black holes are dancing, spiraling closer, faster, wrapping each other in gravity's embrace. Each orbit distorts space, sending out ripples that spread across billions of light years. By the time they reach you, they've stretched and compressed the very fabric of reality by less than the width of an atom. Yet, here in this timeless drift, it feels colossal. It's as if the universe itself is exhaling an endless, deep vibration that passes not through your ears, but your entire being. You remember the story. In 2015, scientists at LIGO detected gravitational waves for the first time. Two black holes, 30 times the mass of the Sun each, collided, releasing energy equal to 3 solar masses, converted entirely into gravitational radiation in less than a second. It was the most powerful event humanity had ever heard. Einstein predicted it a century earlier, and even he doubted anyone could ever detect such a tiny signal. But there it was, a faint chirp that confirmed space-time wasn't just a stage. It was a living, moving thing. You smile at the irony. Even black holes, the great absorbers, make noise when they dance. And not just any noise. Scientists converted those signals into sound waves, tiny upward chirps that last less than half a second. You've probably heard it online. A quick whoop, simple, gentle, almost playful. The death cry of stars reborn as music. You let that sound play in your mind now. Slow it down, stretch it until it feels like breathing. Maybe, if you listen carefully enough, you could fall asleep to it, the universe's quiet percussion. A thought floats up. If space can sing, what else might it whisper? In 2003, astronomers discovered a black hole in the Perseus galaxy cluster, emitting waves in hot gas ripples that correspond to the lowest note ever recorded, a B-flat, 57 octaves below middle C. You'd need 10 million years just to hear one oscillation, the deepest hum imaginable, the kind that could make the bones of galaxies tremble. You wonder if you can feel it now, the slowest heartbeat in existence. The sound, so deep, it's more like stillness, pretending to be motion. It's comforting, in a strange way. The universe is not silent. It just speaks in a frequency too slow for impatience. You float among those vibrations, tracing the echoes of mergers long gone. Some of them are recent, cosmically speaking, others so ancient they ripple from before Earth's crust had cooled. You think about the detector's giant laser arms on Earth, waiting for the slightest tremor, and you can't help but laugh softly at the absurdity. Humanity built instruments to hear the universe sigh. That's dedication. Or insomnia. Possibly both. A nearby gravitational wave rolls through you now. It doesn't hurt. It's like being part of a long, deep ocean swell. For a brief instant, the space around you stretches, then relaxes. You can't help but wonder how many of these waves have already passed through your body while you slept on Earth, completely unaware. Scientists estimate thousands pass through every year, rippling gently through everything. You've been part of cosmic music all along. You just didn't have the volume up. The sound builds around you now, merging with memory, light, and the faint shimmer of quantum static from the event horizon. You can almost make out melodies' collisions turned into harmonies, decay into rhythm. If black holes are instruments, then the universe is a symphony. Each one plays in space-time's key, tuned not by matter, but by gravity. And the fascinating part? Every black hole rings differently after a collision. Scientists call it the ring-down phasor period, when the new, merged black hole vibrates like a struck bell, emitting gravitational waves as it settles into stability. From those ripples, physicists can measure its mass, spin, and even test whether Einstein's equations still hold true. But here's where it gets juicy. Some theorists argue those ring-downs might contain faint echo signatures that could reveal if event horizons aren't perfectly smooth, or if new physics lurks just beneath them. Scientists still argue whether these echoes are real or just wishful interpretations of noise. But you kind of love that uncertainty. It means the universe still has secrets. It still flirts with you, never fully undressing its mysteries. You drift deeper into that resonance, feeling each vibration slow your thoughts. The rhythm is steady now, predictable. It feels like waves lapping against a cosmic shore. The darkness around you glows faintly, not with light, but with pattern. The lines of space stretch and fold, making visible the geometry of sound itself. The ripples overlap, like concentric circles on a pond. Only here the pond is reality. You float in the middle, the calmest spot, the node where frequencies cancel into peace. This, you realize, is what the heart of the universe sounds like. Not chaotic, not violent, but profoundly organized. Even destruction obeys harmony. It's funny to think that black holes, those symbols of void and silence, are among the loudest entities in the cosmos. They scream in gravity, hum in light, and whisper in radiation. You let out a slow breath you didn't realize you'd been holding, though breath is just a memory now, and let that sound cradle you. Maybe that's why humans love white noise. Maybe, deep down, your brain remembers these frequencies from before you were born, from when the cosmos first hummed matter into being. Everything sings, you think, even the dark, and as you drift with that thought, you realize you've stopped resisting it. The hum, the pull, the silence, they're all part of one eternal lullaby. The universe doesn't just exist, it performs. The hum fades until it feels like you're resting on the smallest vibrations imaginable, little pops and flickers of existence, so tiny they barely qualify as real. This is where the solid universe begins to blur. You're hovering now in the realm of quantum foma, restless, bubbling sea at the smallest conceivable scales. If space-time were water, this would be its surface seen under a microscope, jittering, shimmering, constantly reshaping itself. Everywhere you look, or rather, sense space ripples with ghostly sparks. Pairs of particles appear, embrace briefly, and vanish again, like dancers made of probability. It's strangely cozy. You can almost imagine them as tiny fireflies beneath a cosmic bedsheet, winking in and out of being, creating the faint static that gives black holes their quantum warmth. At this scale, the rules change. Nothing is continuous anymore. Everything's granular, like digital noise at the edge of reality's resolution. Scientists think this foam fills all of space, even the emptiness between galaxies. It's not nothing. It's potential. Every point a brewing possibility for particles, energy, or even new universes. The idea came from physicist John Wheeler, the same man who named black holes. He described it as the frothy texture of space-time itself at the Planck scale, a trillion times smaller than an atom. You picture it now, a froth of invisible bubbles, each one a fleeting experiment by the universe to see what else it could be. You drift between those flickers, weightless and infinite, realizing that even here, nothing is ever still. Somewhere above you, though direction has lost meaning, a black hole interacts with this foam near its horizon. Quantum effects intensify, warping the fabric even more violently. The boundary between what's inside and what's outside becomes blurred, and that's where the magic happens. Those particle pairs that pop in and out, sometimes one falls in while the other escapes. That's the mechanism behind Hawking radiation. The black holes, faint, ghostly glow you learned about earlier. One particle carries positive energy away, while its partner, swallowed by the black hole, has negative energy, slowly reducing the hole's mass. It's quantum foam feeding on gravity. The irony is almost comical. The most stable, inevitable structures in the universe slowly dissolve because of microscopic quantum randomness. You let that contradiction sink in. A thing born from perfect collapse, undone by perpetual flicker. It's as if the universe has a built-in joke about permanence. There's a fringe idea, one that feels a bit rebellious. Some physicists propose that at these scales, space-time might not just foam but actually fluctuate into wormholes. Tiny, ephemeral tunnels constantly forming and evaporating, connecting distant regions of space. You imagine miniature portals fizzing around you like soap bubbles, each one opening for a fraction of a second before popping. You reach toward one, and for an instant, your awareness flickers somewhere else entirely. A different patch of space, a different moment in time before snapping back. Maybe the universe is riddled with these tiny shortcuts, invisible but ever present. Scientists still argue whether these micro wormholes could be real, or if they're just math's playful illusions. But even the thought of them makes space-time feel more alive. It's a kind of breathing creation and annihilation, contraction and expansion, all happening beneath everything you've ever known. At this depth, even the idea of a point stops making sense. The foam isn't made of locations, it's made of relationships. Space doesn't exist. First it emerges from the network of interactions between these quantum events. You chuckle softly. So, space is basically gossip with tiny fluctuations, constantly talking to each other about where they should be. And time? Just the order in which the gossip happens. You relax into that image. The universe as a quantum conversation, billions of years long. Each flicker of foam a word, each particle a punctuation mark. It's humbling realizing that everything, planets, galaxies, even you, arises from this chaotic whisper. Somewhere in that whisper, you sense an echo of your own thoughts. Maybe consciousness itself is another form of quantum foam, fluctuating, shimmering, vanishing when observed too closely. That's the thing about deep physics. It starts describing the cosmos and ends up describing you. A stray photon drifts past one born from Hawking radiation, carrying with it the faintest trace of information from the horizon above. It's ancient light, stretched thin by time, yet it vibrates with meaning. You follow it for a while, imagining it's the last breath of a black hole, the last syllable of a story that began with a star, and in that faint glow, you catch a glimpse of something else. A distortion, a twist in the foam itself, a doorway forming out of probability. It's unstable, unpredictable, but calling you nonetheless. It feels like the universe saying, "You've learned to listen. Now come and look." You drift closer, drawn into its shimmering outline, and realize you're about to fall through something stranger than even a black hole. The moment you cross that flickering threshold, everything flips. Direction, light, sense of motion. You're not falling anymore. You're being released. The tunnel around you isn't dark. It's iridescent, shimmering with shifting geometry. It stretches, folds, and contracts, like reality trying to remember its choreography. You've slipped into speculation, the realm of white holes and wormholes. If black holes are cosmic drains, white holes are the hypothetical fountains. They're the time-reversed mirrors of their darker twins, objects that can't be entered, only exited. Matter and light burst out of them, but can never fall back in. You glide through this theory made real, or maybe dreamt real. A white hole could be what happens when a black hole dies, its long silent core suddenly exhaling everything it's ever consumed, like a final cosmic sigh. Scientists still argue whether such things could exist at all. Some say they violate entropy, the universe's favorite rule. Disorder must always increase. Others whisper that white holes might be connected to black holes through Einstein-Rosen bridges, wormholes that link two regions of spacetime. And if that's true, you think, then falling into a black hole might not mean annihilation. It might mean emergence somewhere else, sometime else. The possibility is intoxicating. You imagine drifting down a black hole's throat, only to emerge from another's mouth in a completely different galaxy, or maybe another universe entirely. A cosmic subway system, with space-time as its network and singularities as the stations. You can't help but smile at the image of scientists trying to map such a system. Next stop, Andromeda. Please mind the event horizon. Of course, there's a catch. There's always a catch. The math says that wormholes, if they exist, would be violently unstable. The instant anything tries to pass through, they collapse. Unless, that is, something exotic like negative energy holds them open. And here's where the quantum foam you just left starts to make sense again. Those flickering fluctuations could, theoretically, provide just the right conditions to stabilize a wormhole for a moment. A tiny window through which something, maybe even you, could slip. A few researchers have even proposed that microscopic wormholes might constantly appear and disappear within black holes themselves. Not the sci-fi kind big enough for ships or explorers, but bridges for particles, information, or even entanglement. You feel yourself stretch again. Not painfully this time, but gently. as if your awareness is being duplicated across different coordinates. One version of you remains here, while another skims the exit of a white hole light years away. Both versions share thoughts, connected by a thread finer than time. That's quantum entanglement, two systems behaving as one, no matter how far apart they are. Some physicists think entangled particles might be connected by tiny wormholes, a concept known as ER equals EPR, named after Einstein, Rosen, Podolsky, and Rosen again. Physics loves a callback. If it's true, then the entire universe might be woven together by invisible tunnels of correlation. Every atom, every photon, secretly holding hands with another across the cosmos. You let that image lull you the universe as an infinite web of relationships, softly glowing with hidden symmetry. Nothing isolated, nothing truly lost. The white hole ahead flares brighter. You can almost see through it. Now fields of stars swirling in the distance, time running the wrong way, explosions rewinding into calm. Matter isn't falling in, it's being expelled, coolly and effortlessly, like reversed rain. A quirky idea floats by. Some cosmologists have speculated that our own Big Bang could have been a white hole, the rebirth of a collapsing universe that came before. A cosmic cycle, where death on one side becomes birth on the other. Maybe you're not watching a wormhole, but the memory of creation itself. You drift closer, and the light spills around you, warm and steady. It feels alive, but patient. The jets of expelled matter move in slow arcs, like paint swirling on water. Every photon in that stream once belonged to something, a planet, a person, a story consumed long ago by a black hole on the other side. Now, re-emerging, released into the next act. It's comforting, this idea of cosmic recycling. Even destruction has an afterlife. You reach the mouth of the white hole, and instead of being expelled violently, you're unfolded. The sensation is gentle, like pages turning in reverse. You realize you're traveling through a wormhole not as a traveler, but as a thought. The tunnel's walls shimmer with information waves of quantum data, swirling like auroras. Each pattern feels familiar, as though you've seen it before. And then you understand, these are the memories of the black hole you fell into, flowing back outward. All that talk of hair, of information preservation, it's here. The black hole didn't destroy anything. It simply held it, reprocessed it, and returned it, transformed. Some scientists joke that maybe black holes are just very patient computers, compressing information until the universe asks for it back. You chuckle, because that means right now, you're being downloaded. Your awareness blurs as you emerge into open space again. Stars shimmer nearby, young, bright, and impossibly close. You could swear they're watching you. Somewhere, behind you, the wormhole closes with a soundless sigh, leaving only ripples in space-time. And for the first time in this journey, you're outside the black hole entirely. Free, but changed. You can feel it in your perception. Time doesn't flow the same way anymore. It's become elastic, gentle, forgiving. And though you can't quite prove it, you sense the black hole still connected to you, like a heartbeat echoing across infinity. You drift through the new light, like a dandelion seed carried on the breath of creation. The black hole, your dark host now, glows faintly behind you, its twin jets threading through the cosmic fabric like luminous needles stitching galaxies together. It's strange to think, those same violent engines of destruction, also build the universe. Supermassive black holes, millions or even billions of times the sun's mass, sit quietly at the centers of galaxies. Like hearts, they beat invisibly, regulating the rhythm of cosmic life. They don't merely consume, they shape. Their gravity governs how stars orbit, how matter clumps, how galaxies evolve. When they feed, they don't dine in silence. They roar with radiance, releasing quasars, blinding fountains of energy that can outshine entire galaxies. And yet, even in their hunger, they nurture. The winds and radiation they emit seed nearby space with the ingredients for new stars. Every collapse fuels another creation. You picture it, an immense cosmic heart, pulsing in cycles of consumption and renewal. Every beat of gravity echoing across light years, setting the tempo of existence. Astronomers have found them everywhere, from modest galactic centers to giants like Sagittarius A*, the black hole at the heart of our own Milky Way. It's about 4 million solar masses, yet it rests mostly quiet, a sleeping dragon surrounded by dust and orbiting stars. If you could watch one of those stars dance around it like the famous S, you'd see the unmistakable pull of something invisible, something with an appetite measured in light years. And still, it slumbers. Scientists believe every large galaxy has one of these titans. They might even have grown together, galaxies colliding and merging, their central black holes spiraling toward each other in an elegant, terrifying waltz. You close your eyes and imagine two galaxies embracing, their halos mingling, their stars weaving through each other like fireflies in slow motion. At the core, their black holes orbit, draw closer, and finally merge, releasing gravitational waves, those faint ripples in space-time itself. You don't hear them with your ears, but you can feel them, the low, rolling hum of the cosmos breathing in and out. Each ripple carries a story. Two singularities finding each other, blending into one, and sending their unions echo across the universe. Somewhere, instruments like LIGO and Virgo are listening. They don't just observe, they listen to the fabric of reality, tuned to frequencies far below the edge of human hearing. The signal of a black hole merger lasts only seconds, yet it traverses billions of years and unimaginable distances to reach us. It's humbling, isn't it? You're lying in bed, wrapped in the soft blanket of night, while space-time itself whispers love songs of colliding galaxies. You think of how these mergers might build the supermassive black holes at the centers of galaxies, feeding them through cosmic time. You think of how their energy sculpts nebulae, scours space clean, makes way for new stars. Black holes, it turns out, are not cosmic endings. They're the sculptors of beginnings, the quiet architects of balance. You imagine drifting through one now, a newly merged black hole, still ringing from the union, still glowing faintly from the friction of its creation. The space around it ripples like water, spreading outward in perfect concentric waves. Each ripple passes through you, slow and steady. You can feel the geometry of space-time, undulating, gentle, rhythmic, soothing. It's the closest thing to a heartbeat the universe has. And for a moment, you synchronize with it. You realize this rhythm has always been there. Every atom in you was once part of a star, part of a collapse, part of the same cycles the black holes regulate. You're not outside of them, you're within their pattern. As you float in that understanding, you notice how the light from nearby stars seems to dim and brighten, like breathing. The galaxy itself pulses faintly, responding to the gravitational orchestra of its hidden core. There's no chaos here, no violence, no end, only flow. The black hole doesn't dominate, it participates. It gives structure to chaos, order to the infinite. You drift closer to Sagittarius A*, imagining the vast accretion disk of gas and dust circling at nearly light speed. The heat is unimaginable, yet from a distance, it looks serene, like a cosmic halo glowing softly in the void. And in that glowing edge, you see reflection after reflection of yourself, your awareness folding through time, orbiting the infinite. Each orbit feels slower, each thought lighter. The hum fades into stillness. You realize that maybe falling asleep isn't so different from falling into a black hole. Not an ending, but a gentle surrender to gravity, to the natural pull of the universe drawing you inward. No fear, just inevitability, just calm. The cosmic heart beats once more. You feel it through your whole being. The light fades to a deep indigo. You're ready to sink into the next layer of the void. The light around you drifts and softens until it becomes something else entirely, information itself, whispering across the horizon of a black hole. You sense it more than you see it, like static at the edge of a dream. The photons, the matter, the memories of everything that ever fell in, they're all here, pressed thin across the event horizon. Encoded like grooves on an ancient vinyl record, the universe keeps replaying. This is where one of the strangest, most mind-bending questions in science hides. Does information ever truly disappear? Because according to classical physics, once something crosses that boundary, it's gone, erased, deleted from existence, as if the universe itself hit shift plus delete and never looked back. But quantum mechanics absolutely hates that idea. Quantum theory insists that information cannot be destroyed. It can only change form. Burn a book, and its information isn't lost. It's scattered in ash, heat, and light. So what happens when that book, or a planet, or you, falls into a black hole? You might think the answer is simple. Goodbye forever. But physicist Stephen Hawking made everything more complicated, beautifully complicated, when he proposed Hawking radiation. Tiny quantum fluctuations near the event horizon can create pairs of particles, one falling in, the other escaping. To distant observers, it looks like the black hole is slowly leaking energy, evaporating over unimaginable timescales. And here's the twist. If black holes evaporate, then what happens to the information inside them? Does it escape with the radiation? Does it stay trapped in some holographic imprint? Or does it vanish, leaving the laws of physics with a gaping contradiction? Scientists still argue whether the universe keeps perfect cosmic records or occasionally forgets a few details. It's the great information paradox, and it keeps physicists awake at night. Although, hopefully, not you. You drift deeper into the concept. Imagine every photon, every atom, every moment of you recorded not within the black hole, but on its surface, encoded as microscopic ripples in space-time, like the universe's strangest sticky note. This idea, called the holographic principle, suggests that our entire 3D universe might actually be a projection of information stored on a 2D surface somewhere. You, me, the stars, all holograms in a cosmic cinema. You can help but smile sleepily. So I'm basically light on a wall. You mumble to yourself. That explains my morning hair. It's comfily. The thought drifts and softens into the next one. If the holographic view is true, then even as black holes consume matter, they're not truly destroying anything. They're transforming it into encoded information woven into the horizon, like embroidery in space-time's fabric. Maybe that means nothing is ever really lost, only rearranged, like memories reshuffled in a dream. You picture the radiation flowing outward, faint but endless. Each photon carries a whisper of what once was a molecule, a thought, a planet's entire geological history, all blurred into thermal noise. If you could listen close enough, the universe's background hum might contain every story ever lived. And you realize that perhaps that's what dreams are. The brain's way of decoding a few scattered photons from the cosmic record. Somewhere, researchers still argue over whether the information leaves as tangled quantum states and tangled pairs that keep their secret handshake across the horizon, or whether black holes really do break the rules. One side says physics is neat, logical, reversible. The other says, sorry, chaos wins. And there you are, suspended between them, watching the argument play out across the curve of space-time. It's oddly comforting. Even the smartest minds in existence are baffled, just like you when you lose your keys. A stray thought flits by. If information never disappears, then nothing truly does. Every joke you ever told, every sigh, every starlight moment, it's all somewhere, recorded in the cosmic ledger. You start to see the black hole differently, not as a destroyer, but as a librarian. A strange, grumpy one. Yes, but one that files every particle precisely, storing the record on its shimmering surface. You float closer and notice faint fluctuations rippling across the event. Horizon quantum flickers, spelling secrets in a language you almost understand. They looked like code, the code of everything. You imagine the equations whispering in your ear, soft as wind. Nothing is ever truly gone. And for a moment, that feels deeply human. The idea that memory persists, that nothing good or beautiful is ever lost, just transformed into light we can't yet read. You let that thought settle in your chest like a warm star. The black hole hums, a steady low tone beneath your awareness. Somewhere beyond, scientists run simulations, feed qubits into artificial horizons, and chase paradoxes through chalk-filled rooms. You're here, adrift, watching their collective dream unfold. Maybe that's the secret comfort of cosmic mystery. It's not about finding answers. It's about knowing there's more to find. And with that, you let the hum dissolve into quiet. The equations fade to mist, and you drift onward toward the subtle warmth of the next great truth, waiting just ahead. The hum of encoded light fades, until only warmth remains, the faint, paradoxical heat of a black hole that shouldn't be hot at all. You hover there, sensing it. Not a fire you can see, but a soft, invisible radiation trickling from the horizon, photon by reluctant photon. Each one carries a whisper of entropy, a tiny piece of the black hole's story. This is black hole thermodynamics, where gravity and quantum theory meet for tea and politely pretend they understand each other. Stephen Hawking showed that black holes have a temperature proportional to their surface area and inversely proportional to their mass. The smaller they are, the hotter they get. A stellar mass black hole glows faintly cold, colder than the cosmic microwave background. But a microscopic one would blaze brighter than the Sunday. You can almost feel that paradox in your bones. An object made of nothing radiating something, a hole that glows. It's the universe's version of a cosmic irony joke. You float in that paradox, feeling the faint pulse of heat across your imaginary skin. It's delicate, more a vibration than a sensation, like standing near the edge of a distant bonfire on a cold night. And it means black holes aren't eternal. Over incomprehensible spans of time, they slowly lose mass, evaporating through Hawking radiation. Every photon they emit carries away a bit of their essence. Eventually, they vanish, completely leaving behind only heat, information, and a sigh of space-time. But don't worry, you're not about to wake up to the sound of your local black hole sizzling away. Most will outlive the universe itself. You imagine the last ones glowing faintly in a darkened cosmos, surrounded by nothing but the echo of their own heat. The ultimate campfires in the night of time. It's comforting, somehow, that even endings in the universe come with a kind of warmth. Now, in classical thermodynamics, heat flows from hot to cold, energy disperses, and entropy always increases. In other words, the universe gets messier over time, but black holes turn that law into poetry. Their surface area, called the event horizon area, acts as a measure of their entropy. The bigger the black hole, the more disordered it is, the more information it contains. So when matter falls in, the black hole's area grows and entropy increases, just as the second law demands. It's cosmic bookkeeping at its most elegant. Yet again, scientists still argue whether that simplicity hides deeper complexity. Maybe the horizon's surface isn't just an abstract mathematical shell. Maybe it's a literal physical membrane, woven with quantum threads, each storing a bit of data about the universe it devoured. You picture that surface like a fabric stretched taut warm, alive with flickering patterns that shift and shimmer, with every thought, every photon, every atom absorbed. It looks less like destruction and more like transformation. You drift closer. The warmth deepens. For a moment, it feels like basking under a gentle sun, filtered through thick clouds. The light has no color, the heat no source, yet it radiates an unmistakable sense of balance. Every law of physics whispers through it. Conservation, symmetry, inevitability. It's oddly soothing. The universe is keeping its books in order. A random thought drifts in you. Wonder if entropy applies to bedrooms too. You leave your socks everywhere, and somehow the universe smiles, saying, yes, disorder increases. It's a comforting excuse. Cosmic validation for everyday chaos. You chuckle softly, the sound lost in the gravitational hush. The warmth fades slightly, replaced by the cool realization that everything, stars, galaxies, even black holes, obeys these quiet thermodynamic rules. Nothing escapes the mathematics of change. The heat you feel now is the same energy that once powered the Big Bang, now diluted across the void, whispering through cosmic background radiation. And when the last black holes evaporate, that faint warmth will be all that's left. The universe will cool into silence, its final entropy spread perfectly, evenly, irreversibly. But not tonight. Tonight, there's still a gentle glow around you, a cosmic hearth keeping watch. You can almost see the equations dancing in the darkness, like embers, each one a promise that even chaos follows patterns. Even decay has meaning. Maybe that's what dreams are too. Small dissipations of mind energy, entropy at rest. You feel yourself drifting with it. Brain waves smoothing out, breath slowing to the rhythm of cosmic equilibrium. In the distance, you imagine the dying pulse of a primordial black hole, one that's been evaporating since the dawn of time. It flickers once, twice, and disappears in a flash of pure energy. For a moment, that light illuminates everything: the galaxies, the void, or your thoughts. Then it's gone, but the warmth lingers, because nothing truly leaves without leaving something behind. A trace, a photon, a feeling. And so, the universe continues to glow, faint and eternal, even in its decay. You exhale softly. Your mind follows the warmth outward, carried by the quiet radiation of cosmic order, dissolving gently into the night. The heat drifts away like a sigh, and in its place an image begins to form. Blurry, glowing, historic. You recognize it instantly. A fuzzy orange ring encircling a patch of darkness. You're staring at the first ever photograph of a black hole, the one from galaxy M87*, captured in 2019 by the Event Horizon Telescope. It's not a photo in the everyday sense. It's the echo of data, stitched together by telescopes spread across the entire planet, synchronized to act as one giant eye. Together, they resolved the unseeable. What they found wasn't an object but an absence, a shadow cast by gravity itself. The bright ring isn't the black holes. It's the light from hot gas, swirling just outside the event horizon, compressed and bent by space-time. The dark center, the shadow, is where light cannot escape. You imagine the entire planet holding its breath as that image appeared. Humanity, for a brief moment, saw the unseeable. It's funny, really. Our species spends thousands of years staring at the stars, and when we finally look deep enough, what we find is darkness. But somehow, that darkness shines. You float closer to that ring of fire, orbiting gently through the glow. Each photon you see has been twisted, delayed, redshifted by gravity's endless games. It's like watching time itself take a slow bow. And if that wasn't enough, we've now captured Sagittarius A times 2, the supermassive black hole at the heart of our own galaxy. Same method, same eerie beauty. Only 4 million suns heavy, lounging quietly behind a curtain of dust, waiting patiently for us to notice it. The two images together, M87 times and Sagittarius A*, feel like cosmic portraits, one enormous, one local, both showing that even absence can have structure. Even nothing can be shaped by light. You drift in front of M87 times now, hypnotized by its symmetry. The orange ring flickers, alive with motion. Plasma flows around it at nearly the speed of light. Jets burst from its poles, extending thousands of light years into intergalactic space. You can almost hear the hum of charged particles spiraling through magnetic fields, like a slow jazz riff played by the universe itself. Scientists used supercomputers to reconstruct that image, petabytes of data gathered from across continents. They turned equations into art. And yet, even with that achievement, we've barely touched the surface of understanding. We can't see inside. We can't yet prove what happens beyond the horizon. The shadow is both answer and question. Still, that doesn't stop us from dreaming. Some think we might one day use these images to test Einstein's theory of relativity with unmatched precision, to see whether space-time bends exactly as he predicted, or if the edges of reality start to fray. Others imagine using these same techniques to peer even deeper, to map how black holes spin, or to detect exotic objects, boson stars, perhaps that mimic them. Scientists still argue whether those glowing halos could hide something even stranger, something that breaks the known rules. You chuckle softly. It's nice to know the cosmos has secrets left Otherwise, what would we stay up for? You glance back at Earth, just a blue marble faintly reflecting sunlight, orbiting its star without fuss. Down there, billions of humans scroll through their feeds, sipping coffee, sharing the image of M 87 times and typing, "Looks like a bagel." You can't help but smile. Even the grandest achievements in human history get memed within hours. There's something profoundly grounding about that. And yet, behind the humor lies the quiet realization that from our tiny perch, we can gaze across 50 million light-years and actually see a piece of the impossible. That fuzzy orange ring isn't just data. It's proof that our collective curiosity can pierce the dark. You remember the moment the image was revealed. The scientists, eyes wide, holding up that glowing ring on the screen. The applause, the tears, the laughter. It wasn't just a discovery. It was confirmation that we belong in this story. We, fragile, curious creatures, can look into the abyss and find beauty staring back. You drift closer until the glow fills your vision. The plasma ripples. The light feels warm, intimate, familiar. You realize it's not so different from the warmth of a candle flame or the fading sunset outside your own window. Maybe that's why it feels comforting. It's the same fire, just on a cosmic scale. The photons that reach your mind now are millions of years old, yet they carry a message perfectly intact. Light remembers. And for a second, you imagine those photons have traveled all this way just to find you, to brush against your mind before fading forever. You let them settle on your skin like golden dust. Somewhere, an astronomer adjusts a radio dish. Somewhere else, a student stares at data, finding patterns in the static. And you, drifting, weightless, are part of that same observation. Another consciousness briefly illuminated by the ring. It's a humbling thought. Even the faintest glimmer from a black hole can travel across time and space to reach a sleepy human heart. You breathe in slowly. The light pulses once more. Then, as though the universe exhales, the glow fades into deep velvet shadow again. You are ready to see how the story of black holes finally ends, or perhaps how they quietly disappear. The glow of M 87 times fades into a darkness so complete it feels thick like ink suspended in still water. You drift inside it, suspended, waiting for the next heartbeat of the universe. But none comes. The black hole before you is silent, tired, ancient. You've arrived at the twilight of existence, the moment when a black hole finally begins to die. It happens slowly, painfully slowly. For most of their lives, black holes only grow, swallowing matter, light, and time itself. But deep within their horizons, quantum processes whisper rebellion. Every particle that escapes as Hawking radiation steals a sliver of mass, and as mass shrinks, temperature rises. The black hole glows hotter, brighter, faster until its last moments become a cosmic fireworks show in the coldest night imaginable. You imagine one now, after trillions of years, surrounded by nothing but the ashes of stars. Its event horizon quivers, shimmering with the energy of its final breath. The faint hum of space-time tightens. Higher, sharper, until pop. In a flash of pure radiation, it's gone, just like that. The ultimate heavyweight of creation, erased in silence. Yet, the energy released in that instant could light up galaxies, if galaxies still existed. Instead, it dissipates into emptiness, a lone ripple, crossing the dark ocean of what remains. The universe has grown cold by now. Stars have long burned out. Planets, shattered and silent, drift endlessly. Only black holes remain, scattered across the dark, slowly evaporating one by one like fading coals. This is the black hole era, a time so distant you can't even measure it in years. Somewhere, one last black hole, massive beyond imagination, sits at the edge of time. It glows faintly, a final ember in the infinite dark. You approach it slowly. Its surface is hot now, dazzling in ultraviolet light, but space itself is so empty there's no one left to see. You are a ghost of thought, a fragment of curiosity. You drift closer, watching photons flee for freedom, listening to the hiss of space-time evaporating itself. And then you notice something curious. Even now, information still flows outward. Tiny quantum patterns embedded in the escaping radiation whispers of everything the black hole ever was. It's as if the universe insists on remembering, even at the end. Maybe this is what Hawking meant when he said, "Information never truly disappears." The black hole doesn't die in vain. It tells its story in light before it fades. You imagine that light rippling outward, spreading into the void, carrying with it all the stories of galaxies long gone. Every orbit, every collision, every dream that ever existed, all encoded in that last burst. And perhaps, somewhere beyond this emptiness, that information might seed something new. Some physicists even speculate that when black holes evaporate completely, they might leave behind Planck-scale remnants, tiny, indestructible seeds of space-time itself. Little gravitational marbles that could, in theory, spark new universes. Scientists still argue whether that's possible. Maybe the universe never ends. Maybe it simply reboots. You smile faintly at the idea of a cosmic recycling system, so efficient, even eternity has a return policy. And if each black hole births a new cosmos, then maybe this one did too. Maybe your universe was born from the ashes of another, rising like light from a long-dead horizon. That thought wraps around you, like a blanket, soft, cyclical, infinite. The darkness deepens again, but this time, it doesn't feel empty. It feels full. Every lost photon, every evaporated particle, every memory of existence still hums quietly in the vacuum. The universe itself is whispering its last lullaby. You find comfort in the idea that nothing ever truly ends, it just changes form. Even in the most extreme silence, there's still motion. Even in the blackest void, there's still light waiting to be born. You feel yourself floating with that understanding. No gravity, no direction, just the soft tide of space-time receding into peace. If you could look back across all of time, you'd see the grand arc of creation bending toward stillness. Stars flaring into life, collapsing, feeding the black holes that in turn give birth to more. A loop without center, a dance without beginning. And somewhere within that loop, you tiny, conscious, curious, have borne witness. Your breath aligns with the fading hum of the cosmos. Slow, steady, final, and yet comforting, because this ending doesn't feel like death, it feels like rest. The black hole flickers one last time. The universe exhales. Then nothing. But in that nothing, you hear the echo of a truth older than light. Everything that was will be again. Silence fills the void now. Not the kind you hear, but the kind you feel, a smooth, eternal stillness that stretches in every direction. It's softer than thought, slower than time. You drift through it weightlessly, a ripple in the fabric of space-time that no longer needs to go anywhere. The last black hole has dissolved. The last photon has cooled. The universe rests, vast and content. And you rest with it. The paradoxes are gone. The equations no longer argue. Everything that once competed now coexists in perfect calm gravity. Light, matter, memory, all dissolved into a single, seamless hum. You breathe, or maybe the universe breathes through you. For a fleeting moment, you imagine the entire cosmos as a sleeping creature. Its dreams ripple across infinity, folding reality into soft spirals. Galaxies become thoughts. Black holes become slow heartbeats. Even in sleep, it remembers. You drift along one of those dreams, tracing the faint echo of a spiral arm, past where stars once blazed and planets once whispered life into the dark. You pass through the afterglow of creation itself, stretched thin by time, now only a cool sigh of radiation. It hums to you, gentle, low, steady. And maybe that's what peace sounds like when all of existence has exhaled. You realize that somewhere, in some hidden pocket of quantum foam, fluctuations are stirring again. Tiny bubbles of space-time, swelling, collapsing, trying again. Maybe one of them will grow. Maybe one of them already has. Maybe, inside that flicker, a new universe is forming, a blank page written in the ashes of this one. And in that universe, there's another sky, another night, another mind, wondering what happens when the lights go out. You smile faintly, cycles within cycles, dreams within dreams. The thought makes you feel small, but not insignificant. You're part of the recursion, an echo of the universe contemplating itself. Even in stillness, meaning remains. The hum softens further, fading into something more intimate, a steady rhythm, like a heartbeat slowed to infinity. You feel it against your consciousness, a pulse in the fabric beneath you. It's not the heartbeat of a black hole now, it's your own. You breathe with the cosmos slow, even, infinite. Every inhale gathers what's left of time. Every exhale releases it. There's no distinction between you and the universe anymore. No boundaries, no edges, no horizon. Just smooth, endless continuity. The questions fade. What is beyond? Where does it end? What does it mean? All that remains is the sensation of being held by gravity, by history, by everything that ever was. You realize this is the real singularity. Not infinite density or impossible physics, but infinite peace. Everything converges here. All contradictions resolve. All energy balances. Even thought itself slows until it becomes nothing but warmth. The universe doesn't end, it exhales. And in that exhale, you dissolve with it. For a while, there's only the rhythm of your breath and the faint whisper of time rolling into forever. You feel lighter with every second. Your mind softens, your body loosens, every atom resting back into the background hum it came from. This is where you belong, not as a bystander, but as a note in the cosmic lullaby. The same lullaby that stars once sang when they burned, the same one black holes hummed while swallowing light, the same one you now carry quietly in your own chest. Everything returns to it, sooner or later, and as you float there, dissolving into that gentle melody, you hear it one last whisper through the dark. You are the universe resting in its own arms. The sound fades, but the feeling remains soft, endless, kind. You drift off with the certainty that somewhere, light is rising again. Somewhere, new worlds are waiting to dream. And for now, here, in this infinite quiet, you can finally let go. Sleep well, traveler. Sweet dreams.